Today we did day 3 of comparing and ordering fractions. First, you made your models. You may have chosen bar models or number lines. Then, we talked about finding common denominators. We talked about how common means the same and how denominator means the number of total pieces in the whole. Then, we worked on finding common denominators by listing out our multiples of 4 and our multiples of 10. So our multiples of 4 would be 4, 8, 12, 16, 20, 24, 28, 32, and 40. Once we get to 10 multiples, that's typically enough. Unless we don't find any numbers that are the same, then we would continue. Our multiples of 10, counting by 10s are easy. 10, 20, 30, 40. Okay, I can see that I already have 40 and 40. Those are common multiples. However, we are looking for the least common multiple. So, I would say, all right, were there any numbers starting at the beginning? 4 was not a multiple of 10. 8, not a multiple of 10. 12, not a multiple of 10. 16, not a multiple of 10. 20 is a multiple of 10. So our least common multiple, which least means smallest, common means the same, and multiples are what we just did up here. So which is the smallest number that is the same? Well, that would be 20. 20 is our least common multiple. And sometimes least common multiple is written as LCM. But when we see LCM, we still say least common multiple is 20. So, now we're going to take 3/4 and 7/10. We're going to now compare 3/4 and 7/10 using our least common multiple. Our least common multiple will be 20. So we're going to find that when we compare, we're going to find an equivalent fraction of 3/4 that has a denominator of 20 and an equivalent fraction for 7/10 that has a denominator of 20. I'm going to model these for you. So first I'm going to draw my whole for 3/4. Then I will come below it and draw the same size whole, because we're finding equivalent fractions, for 7/10. So these are both equal to 1 whole. And they start and end at the same point. So here, for 3/4, my denominator is 4. So I will be making my whole into 4 pieces. We begin by cutting it in half, partitioning it in half, and then we partition each half in half. Now I have 4 pieces. I'm going to shade in 3 of those pieces. Okay, now 7/10. Because we have tenths as our denominator, I need to make tenths of my lower whole. So I know that 10 can be divided by 2, so I'm going to partition it in half, and then each half will be partitioned into fifths. Each half will be partitioned into fifths. I didn't do a great job on that. Let me go back and fix that. Okay. All right. And how many will I shade in? I'm going to shade in 7/10. So 7 will be shaded. 1/7, 2/7, 3/7, 4/7, 5/7, 6/7, 7/7 shaded. Now, we're going to put both of these into 20ths so we can tell which one is equivalent, because right here it's hard to tell, especially since I didn't make all of my pieces perfectly equal like our fraction model pieces, our fraction manipulative pieces, excuse me. So there are 4 pieces here. If I wanted there to be 20, I need to say, well, what can I get? What times 4, because we have 4 pieces, equals 20? 5. So there should be 5 pieces here, 5 pieces here, 5 pieces here, 5 pieces here. I'm going to partition each of my fourths into 5 pieces each. So I take a piece out of the middle, and then these larger pieces on the side, I'm going to partition in half. Now I have 1, 2, 3, 4, 5 pieces inside my original fourth. We're going to continue doing that. Take a piece out of the middle and partition the larger sides. Take a piece out of the middle and partition the larger sides. Take a piece out of the middle and partition the larger sides. Now you are going to count. Do I have 20 pieces? I want you to pause the video and count. Do you have 20 pieces? Yes, we have 20 pieces. So we took our fourths and we partitioned them each into 5 pieces, because 4 times 5 is 20. So over here, we're going to say, all right, 4, if we make each of those fourths into 5 pieces, we get 20 pieces. Now, 3 of our fourths were originally shaded in. Here are 3 original fourths that are shaded in. Now, there are how many pieces shaded in? Pause the video and count how many are shaded in pink. Right, there's 15, because we had our 3, and then we had 5 pieces made out of those 3/4. So now we have 15. Our total here is 15 20ths. Now remember, we used our least common multiple, 20, to partition these into 20ths. So we need to partition our tenths into 20ths. So now you're saying, what times 10, because there's 10 pieces here, equals 20? You know it. 2 times 10. So each of our pieces are going to be partitioned into 2 pieces. So we'll have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 pieces. So go ahead with me and partition each of the pieces in half. Count. Are there 20 pieces? Pause the video to do that. Yes, there are 20 pieces, because 10 times 2 equals 20. And I wrote that over here. Now, there were 7 shaded originally. Now, how many are shaded now that we have 20 instead of 10 pieces? Now, there's 14 shaded, because 7 partitioned into 2 pieces each equals 14 pieces. So we have 14 20ths. Now we're comparing 15 20ths, this much, and 14 20ths, this much. Which is larger? 15/20 is slightly larger than 14/20. So because 15/20 is the same as 3/4, 3/4 is greater than 7/10. Because 14/20 is the same as 7/10. So 3/4 or 15/20 is larger. So we would put our greater than sign, and we have figured it out. So our goal, today we're going to show with the models, but our goal is to eventually be able to do it with just using the equations and comparison statements. All right. Next we have the problem 5/8, and we have to decide, is it greater than, less than, or equal to 8/12? So I'm thinking when I look at 5/8, is 5/8 closer to 0, half, or 1? Well, if I have eighths, I know that 8/8 would be equal to 1. 0/8 would be equal to 0, so 4/8 would be equal to half, which means 5/8 would be somewhere in here. Now, if I use my benchmark fractions to also think about 8/12, I know that 0 would be 0/12, 1 would be 12/12, and half would be 6/12, because 6 is half of 12. Which means 8/12 is going to be somewhere in here. Can I tell which is larger, 5/8 or 8/12 by these number lines? No, I can't. Looks like they're like really close to being equal, but we don't know if they're exactly equal, which is why we're going to use our lowest common multiple. So again, we're going to take eighths, because that's our denominator, and we are going to find the lowest common multiple. Skip counting by eighths. Go ahead and pause the video and skip count by eighths. 8, 16, 24, 32, 40, 48, 56, 64. I'm going to stop there. Then we're going to find our denominator and our other number, 12, and skip count by 12s. 12, 24, 36, 48, 60. Okay. What number is the least common multiple? So I look here, I say no, 8 is not in this line, in the 12's multiple. 16 is not a multiple of 12. 24 is a multiple of 12. So even though 48 is also a multiple of both, we are looking for the least common multiple, which is 24. So when we make our bar models, we're going to be making each whole into 24 pieces. Just like last time, we're going to start our bar models in the same place, and we will end them in the same place. So our first bar model will be for the fraction 5/8, found here. And our second bar model will be for 8/12. Second number that we're comparing. We're starting them in the same place and ending our bar models in the same place. Okay. I want you to pause the video and try to make 5/8 here and 8/12 here, remembering to partition how we practiced. All right, we partition in the middle, make fourths, make eighths. Then for 12ths, we partition in the middle, make fourths, and make 12ths by making each fourth into 3 pieces. Then we shade it in. So because we have 5/8 and we have 8/12, we know that our least common multiple is 24. So we are going to find fractions that are equivalent to 24ths. 8 times what is 24? Well, that's easy. We already have them skip counted out. So let's count. 8 times 1, 8 times 2, 8 times 3. 8 times 3 is 24. That means each piece is going to be partitioned into 3 pieces. Each eighth is now partitioned into 3 pieces. Partition the next eighth into 3 pieces. Now count. Do you have 24 pieces? How many are shaded? How many pieces are shaded? Well, 5 of our original boxes were shaded in. There's our 5. And we partitioned each of our eighths into thirds. So we take them times 3. And there are now 15 shaded. And as you counted, there should be 15 pieces shaded in. Now we have 12ths. 12 times what equals 24? Well, we have our numbers. Skip counted out. Let's try. 12 times 1, 12 times 2. 12 times 2 is 24. This 2 means that each of our 12ths are going to be partitioned in half. Go ahead, partition each of your 12ths in half. Do you need more time? Pause the video. Now, count. How many 24ths are shaded in? I counted 16, and I can check my work by saying, well, each 12th was partitioned in half, so I multiplied it times 2. 8 times 2 is 16. So here I have 16 24ths in red and 15 24ths in pink. So which is larger, 15 24ths or 16 24ths? Well, I can see that 16 24ths is 1 24th larger than 15 24ths. So 16 24ths is the same as 8 12ths. So 8 12ths is larger or than 5 eighths. So we would read this, 5 eighths is less than 8 12ths. Awesome job, guys. And I just want to point out that on our number line, that they were very close because they're only 1/24th difference. That's a very small amount. All right, 2/3 is greater than, less than, or equal to 3/5. So I don't want to do a lot of work if I can easily use benchmarks to see which one is larger. So I'm going to think to myself, all right, for 2/3, 0/3 would be equivalent to 0. 3/3 would be equivalent to 1. 2/3 would be in here somewhere. With 3/5, 0/5 would be equal to 0, and 5/5 would be equal to 1. 3/5 is again going to be slightly larger than a half, But these look pretty equal. But we don't know if they're exactly equal. So we need to use common denominators to figure out if they are equal. So I'm going to find my least common multiple for 3, because that's my denominator in 2/3, and in 5, because that's my denominator in 3/5. So I want you to pause the video and count out, skip count, 3s and 5s, and find the least common multiple. Pause the video. All right, we're skip counting by 3s. 3, 6, 9, 12, 15, 18, 21, 20, and we could keep going. Let's skip count by 5s. 5, 10, 15, 20, 25, 30. Ooh, I hope you noticed that we already passed one that was the same. So I really don't need to keep going if I can already see 3 is not a multiple of 5. 6, not a multiple of 5. 9, not a multiple of 5. 12, not a multiple of 5. 15, multiple of 5. Let's circle those. 15 is going to be our least common multiple. So we're going to have 2/3 is equal to how many 15ths? And 3/5 is equal to how many 15ths? Alrighty, you're going to draw your holes, your bar models over here, and you're going to have one for 2/3 and one for 3/5. Make sure that they are the same size. We can't compare them if they don't have the same size hole. Oh, I didn't do a good job of ending those at the same place, so I'm going to erase that and try again. There we go. My second attempt was much better. All right, 2/3. Remember, 2/3, you have to make sure that they are 3 equal pieces. I don't want one of these to be larger than the other 2. Then with 5ths, we take a piece out of the middle and we partition each of our larger pieces in half. Okay, I didn't do a great job at making all the pieces the exact same size. So sometimes I have to go back and try it again. They're a little bit better. All right, I'm shading in my 3/5 and my 2/3. Now in my model, it looks like 2/3 is a little bit larger, but we are going to we already found our least common multiple, so we're going to quickly do the math and see if 2/3 is actually larger. So when I have 2/3, I say 3 times what equals 15, because we want 15 pieces over here. 3 times 5. And 5 tells us that that is how many pieces we're going to break each third into. So we take a piece out of the middle and then partition both sides into halves. Take a piece out of the middle, partition, partition. Piece out of the middle, partition, partition. Count, make sure you have 15 pieces. 15 pieces. How many are shaded in? 10. And we can check because each of our 2 pieces that are shaded in, here's our 2. Each of the 2/3 were made into 5 pieces each. So we're going to write times 5. 2 times 5 is 10. So 2/3 is equivalent to 10 15ths. Now let's try it with 3/5. 3/5, 5 times what is 15? 5 times 3. So each of our 5ths are going to be partitioned into thirds. into thirds, into thirds, into thirds, into thirds. I'm getting sing-songy again. Do I have 15 pieces? I have some sloppy 15 pieces over here. Ooh, clean it up, Miss Stockthorn. Alrighty, how many are shaded in? 9. Because each of our 3 pieces that were shaded in are now partitioned into 3 pieces each, times 3. 3 times 3 is 9. Here we can see that 2/3 is just slightly bigger than 3/5. And 3/5 is the same as 9/15. And see that when we have the same denominator, 15ths, that 10/15 is going to be a little bit bigger than 9/15. So that tells us that 2/3 is larger than 3/5. So over here we're going to write which is the larger number? 2/3. So we're going to eat the bigger number. And this is greater than. 2/3 is greater than 3/5. I'm just really proud of you guys. I know this was a lot of work, but you did an awesome job, so give yourself a star. Yesterday, we worked on these different statements. Is less than a half because, that helps us with our benchmarks. Is equal to a half because. Is greater than a half because. Is the same as 1 whole. So 5/5 is the same as 1 whole. I'm using this sentence. Today, we learned I found a common denominator. The common denominator is the least common multiple, 15. The least common multiple for thirds and fifths, or 3 and 5, is 15. So my denominator is 15 when I am finding equivalent fractions. Now today, what I want you to try are these 4 problems. Here are the directions. You may choose which strategy is best for each comparison statement. 1. Either compare fractions using benchmark fractions, so that would look like this, or compare using common denominators. I'm going to highlight common denominators in pink, and that would be this. Okay. Then, number 2, use the sentence stems above. So we're talking now about these sentence stems. The sentence stems to justify your reasoning. So if I showed, if I thought, oh, one of the numbers is less than half, then I would say, is less than half because, and the other number is close to 1, then I would say, is greater than a half because. Okay, let's try the first one together. 3/10 is greater than, less than, or equal to 4/8. I like to start with benchmark fractions because if they're close, then I will go and find the least common multiple. So I'm going to draw my 2 number lines, and I don't have to make them that big because I'm just labeling 0, 1 whole, and 1/2. Now then I'm going to do it for the other number. And I need to make sure 0 and 1 whole are at the same place. So 3/10. Well, 0/10 would be 0, and 1 whole would be 10/10, which means that 1/2 would be halfway between 0 and 10, which is 5/10. Good job. Now, 4/8. Now I have a number line. My red number line is going to have eighths. 0 will be 0/8, and 1 whole will be 8/8. What's halfway between 0 and 8? 4/8. Perfect. I can see right away that 3/8 is going to be where on my number line? Is it going to be less than half, greater than half, or equal to half? 3/10 will be less than half. Okay, and 4/8, we already have it on our number line, is exactly half. So I can use my sentence stems. Is less than half. Which number was less than half? 3/10. So I'm going to say 3/10 is less than half. I'm going to write that here. 3/10 is less than half because, now what told us that 3/10 was less than half? Well, half would be 5/10. 1/2 is 5/10. And 3/10 is less than 5/10. We also saw that in our next problem, 4/8 is equal to a half because and do you see how I'm using this sentence stem right here? How did we know that 4/8 was exactly 1/2? Well, 8/8 was a whole, 0/8 was a 0. So 4/8 was exactly between 0/8 and 4/8. 4/8 was exactly between 0/8 and 8/8. Super job. Okay, for the next one, I want you to start off trying benchmark fractions. If it doesn't work, then you're going to use common denominators, which look like this. Okay. Go ahead, finish the last 3 problems. Raise your hand if you have any questions.